Then just the question 4 on that sheet is kind of on sequences, series, or patterns. Which one of the following sequences is linear? So for a linear sequence, they're going up in constant first differences. Okay, so that common difference between each term is it's common. It's the same every time. So what about this one? 6 to 4. From 6 to 4 is -2. From 4 to 0 is -4. So that's not linear because the first difference is changing. What about this one? From -3 to -1. That is from -3 to -1 is up 2. So that will be +2. From -1 to 3 is +4. And then from 3 to 5 is +2. But already +2, +4. No, that's not linear. So it must be part 3. Let's just check it though. -5 to -3. That's +2. So you're going from -5 up to -3. -3 up to -1 is +2. -1 to 1 is +2 as well. So that's your linear one, okay? Because you've got your constant first difference, okay? Your first difference is the same, all right? To go over the other ones, quadratic is second difference is the same. So you'd be looking at the kind of difference between these. That'd be +2, that'd be -2, that'd be, you know. And then the exponential ones are you multiply to get from term to term. So we don't see any of that here. Part B then, so you've got a pattern made out of matchsticks. You've got 3 of them drawn for you. You're told that there's 5 matchsticks in the first, which you can count yourself. You're told there's 9 in the second, which you can count yourself to check. The third one, if you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's what I'm counting. What's our pattern? From 5 to 9 is +4. 9 to 13 is +4. So the next one must be 17. And the next one must be 17 plus 4 is 21. How many matchsticks in shape 7? There's a way of doing this kind of using what we're going to get in the next part in part 3, but like I would just continue on your table. So 6 and 7. The next one is going to be 21 plus 4 is 25. 25 plus 4 is 29. So 29 matchsticks in shape 7. Part 3, so this is our TN, our kind of formula for the number of matchsticks in any pattern. So find an expression for the number of matchsticks in shape N. So there's 2 different ways of getting this. Okay, so I suppose the first less formal way I told you is go back to shape number 0. Imagine there was a shape 0. So if we're kind of going backwards here, we're subtracting 4s. Okay, so if there was a shape 0, 5 minus 4, there would be 1 matchstick in it. And then every time you add on a shape, so every time you add on a term, every time you go to the next shape, how many matchsticks do you add? It's +4, and that's +4 multiplied by the number of stages. Okay, so there's always how many would be there in a stage 0 if there was one. Sometimes that stage 0 mightn't make sense. It could even be negative in some of them. Okay, but it's just to kind of help us get this formula, plus whatever this first difference is times n. Okay, so I can check it. So let's say stage 5, 1 plus 4 times 5, 1 plus 20 is 21. As I said, I could get stage 7 using this as well. 1 plus 4 times 7, 1 plus 28 is 29. The other way of getting this then, so there is a formula on page 22 in the log tables. And you can use that if you want as well. So I'll do it using that as well. So the formula is here. And it's the TN one. Okay, so it's TN that we look for. So if you've done this, and that's fine, that's an answer. But if you wanted to see it done the other way, so Tn is equal to A plus N minus 1D. And the formula tells us A is the first term. So here we're looking at the first term. So it's 5. Plus, I want an N in my answer, so I'm not subbing in N, it's a Tn formula. And then D, the common difference, what you're going up in jumps of. So that's 4. All right. And if you look at this, you've got, it's odd the way they put the 4 at the end of the bracket rather than the start, but this is 4 multiplied by both of these. So it's 5, and then 4 times n is 4n. 4 times minus 1 is minus 4. 5 minus 4 is 1 plus 4n. So same formula, okay? And I remind which way you do it. You'll get away with this kind of, as I say, slightly less formal way maybe of doing it at junior cert. You will need to use this at leaving cert though. Just be careful. I suppose I'd say pick one, because just the different way we use the A here, or the first term, the way we go back to 0 on this one. If you're switching between them, you might get yourself a little bit mixed up. So I'd say pick one and run with it. In part 4 then, which shape, oh, and just to say one thing there, I think I had questions on this when we were doing them. Doesn't matter what order they're in, okay? So 1 plus 4n is the same thing as 4n plus 1, okay? Either way around, doesn't really matter. Part 4 then. Which shape contains exactly 101 matchsticks? So that's where this formula comes into its own and makes questions easier. So which shape contains 101 matchsticks? So if you put this equal to 101 and solve for n, it will tell you which stage has 101 matchsticks in it. So just be careful there, the difference between, say, question 2, where it's how many matchsticks are in 7, in stage 7 or in shape 7. So I'd be subbing 7 in for n. And this is which shape or which stage contains 101. So I put it equal to 101 and solve for n. So if I was solving this, subtract 1 from both sides, you get 4n equal to 100. Divide both sides by 4 and you get n equals 25. So it will be the 25th shape or stage. If you didn't get part 3 out, or if you didn't think to do part 3 that way, is there another way you could do this question? Absolutely. Shape number 7 has 29 in it. You're going up in 4s. So shape number 8 would be 33. Shape number 9 would be 37. So just keep going up brute force like that. You're only going up as far as the 25th shape. So it'll take you a little bit longer, but if you have the time to do it, maybe come back to it maybe towards the end of an exam if you're going to do it that way. But it is fine to just go plus 4, plus 4, plus 4, plus 4, plus 4, plus 4, plus 4 till you get to 101. Just if you do it that way, be careful you count the shapes, the shape number or stage numbers correctly.